I'm just saying though. I'm just saying. Young Metro. Ladies and gentlemen, once again, it's Fraser Nation. We're going to talk about sections 7.5 and 7.6. Apply the trigonometric ratios. As you see on your screen, there are three trig ratios, sine, cosine, and tangent. So 1, 2, 3. Students will be able to use trig ratios to find the side lengths of a right triangle. Okay. First and foremost, you need to know the word fraction means ratio. Ratio means fraction. Ratio means fraction. Fraction means ratio. So that means that we're going to be dealing with fractions. The opposite side of a triangle, you want to always draw a straight line from your angle to the side that is across the triangle. So, as I always say, the hypotenuse is always the side across from the right angle. So you got to draw a straight line. So this would be your hypotenuse. Okay. That also works for the other two angles. So adjacent means right next to. And you have to remember that these methods only work with a right triangle. So let's move on. When we're talking about trigonometric ratios, we want to set up a fraction based on what angle you use. Now, I know you don't know what the symbol means yet. This is basically x, but this is the angle that we're talking about. So if we draw an arrow from this angle to this side, this is the side that is opposite. This is the side that right next to, and this is always the hypotenuse because it's across from the right angle. So here are three fractions that I give you. Sine of angle B, which is opposite, divided by the hypotenuse. The adjacent, which would be right next to angle B, divided by the hypotenuse. And the tangent, which would be the opposite, divided by the adjacent. But that's only for angle B. These switch up if I was talking about this angle. There is a word that you can use to remember these three fractions. So let's go ahead and write down that word and what it all means. It's just a shortcut. It's called SOHCAHTOA, and this tells you what fractions to use. So if I tell you sine, you tell me the fraction opposite divided by hypotenuse. If I tell you cosine, you tell me the fraction adjacent divided by hypotenuse. And if I tell you tangent, you tell me the fraction opposite divided by adjacent. Okay? Now this chart I really feel is a little bit more descriptive, a little bit more detailed. You don't have to write it down. But, you know, obviously I'm putting it here because I feel like it's important. So let's get some examples going. So I haven't done this before, so I'm going to go ahead and start punching numbers in when I need to. When I'm talking about tangent J and tangent K, I want to set up a fraction based on angle J and then based on angle K. And then I want to round to 4 decimal places. So tangent, remember it talks about the opposite divided by the adjacent. So let's put opposite divided by adjacent. Okay. So the opposite of angle J is going to be 32. The adjacent, the side right next to, is 24. Because I know that this is the hypotenuse and we're not asking for the hypotenuse. And then 32 divided by 24 is going to be 1.3.3.3.3. Okay? That changes a little bit when you talk about the other angle, angle right here, angle K. So angle K, the side that is opposite is going to be, let's put opposite divided by adjacent. Okay, we're going to be talking about 24, and then we have 32, okay? So if you have 24 and 32, that's going to be 7.5, and then it kind of terminates there. So let's try it again with this triangle. So with angle J, the side that is opposite is 8. This is the hypotenuse because it's crossing the right angle. So we have to be talking about 15. So this is going to be 8 over 15. So if I plug in 8 over 15 in the calculator, you're going to get 0.5333. Okay? And then if I'm talking about angle K, and hopefully this is starting to sink in a little bit. If I'm talking about angle K, here is the side that is opposite of angle K. So it's going to be 15. And then since this is the hypotenuse and we're not talking about the hypotenuse, the adjacent side has to be 8. So go ahead and plug in 15 divided by 8. And you're going to get, wow. Wow, and it just won't let it go. Wow, that just happened. We are talking about 1.875. So that's how you do tangent. There's another way to do these type of problems, and that's if I give you the degree first and then ask for that other side. So first and foremost, we need to find the value of x. If I give you this angle right here, look at the sides that we give you. Okay, so if I draw an arrow here, this is the opposite side. And this is the hypotenuse. So if this is the hypotenuse and this is the opposite, this right here must be the adjacent. So we're going to set an equation up. Okay, so we need equations here. So if I have opposite and I have adjacent, the fraction that fits there is tangent. Okay, so remember I told you tangent of 61, okay, so tangent of the angle is equal to the opposite, which is 22, divided by adjacent, which is x. Okay, and then it's all a matter of trying to solve for x. So we're gonna multiply x on both sides. So x times tangent of 61 is equal to 22 over x times x. And the reason we multiplied on both sides is to cancel this x out. And then I have I'm gonna have x times tangent of 61 equals 22 divided by tangent of 61 divided by tangent 61. Those cross out and you have x equals 22 over the tangent of 61. And if we plug that into the calculator, we're going to get 12.19 or 12.2. So x is going to be equal to 12.2. Okay? Let's try it again. So I have an angle, okay? And here's the side that's opposite. Here's the hypotenuse. So let's put op here. Let's put hypotenuse here. This side is the hypotenuse. So this must be the adjacent side. So we are given the opposite and the adjacent must be tangent. So tangent of 56 is equal to x divided by 13. Solve for x, so we're going to multiply by 13 on both sides. Cross that out. And then so x is by itself. And then when you plug in 13 tangent of 56, we're going to go ahead and get 19.3. Okay? So you got to pay attention to what sides we give you. Was it the opposite? Was the adjacent? The hypotenuse, the adjacent, the hypotenuse, and opposite. And that's how you can solve for x. So the next example talks about finding sine x and sine y, not sin, sine. So sine of x, sine of any angle is going to be opposite divided by the hypotenuse. So let's identify the hypotenuse first. Okay. So across from the right angle, this must be the hypotenuse. Okay, so I'm going to have sine of x is equal to the opposite divided by the hypotenuse. So that's where that's coming from, opposite of hypotenuse. And so the opposite of angle x, okay, is right there. So we have the opposite, which is 8 over 17. And then we want a decimal as well. So we have 8 divided by 17. And we have 0.47. So 0.47. And then let's go ahead and erase a couple of things, because now we're going to be talking about angle y. So I have sine of y. So this is going to be opposite over the hypotenuse. The hypotenuse does not change. The right angle's right here. So the hypotenuse is still going to be 17. But then the opposite of y has to be 15. So this is going to be 15 over 17. And then 15 divided by 17 is going to be 0.88. Okay? So that's how you do that type of problem. So over here, let's go ahead and set this up quickly. So the sine of x, this is the hypotenuse as always. So the opposite of x has to be 15. So this is going to be 15 over 25. And to find that fraction, you plug in the calculator and you get 0.60. Let's see, 0.6, whoa. So 0.60. Let's see if I can put a little decimal there. There we go. And then I have sine of y. So let's go ahead and delete this arrow. Hypotenuse stays the same. So sine of y, we know that the hypotenuse is still going to be 25 on the bottom. And then we're going to go ahead. The opposite of y is 20. So this is going to be 0.8, 4 out of 5. Okay? And then finally, we're going to write cosine of r and cosine of s as a fraction in the decimal. First and foremost, we do not know what the hypotenuse is. We need the hypotenuse. Remember I told you, hypotenuse, we're going to need the Pythagorean theorem. So the hypotenuse is always C, okay? Wow, this pen is just acting crazy. So the hypotenuse is always C. So now I have C squared equals, I don't know what C is, 9 squared plus 12 squared. So this is going to be equal to 81 plus 144. So this is going to be equal to, what, 225? So I have C squared equals 225. My people know that you have to always get rid of this 2. And I always want to see this crossed out. So square root of 225. And then if you plug that in the calculator, square root of 225 is 15. Okay. So the hypotenuse, which I told you is always C, has to be 15. So cosine of R is equal to adjacent over the hypotenuse. Okay. So identify your sides. This is your hypotenuse, okay? And then if this is the opposite of angle R, then this must be the adjacent of angle R, right next to angle R. So this is going to be 9 divided by 15. So there's my fraction. and you plug it into your calculator, and you get 0.6. And then the cosine of angle S, hypotenuse is still going to be 15. And then your sides change because now we're talking about angle S. So if we're talking about angle S, this is your opposite, this is your adjacent. And so that's going to be 12 over 15, which you guys know has to be 0.8. Okay? So go ahead, give your homework a try. I know things are a little confusing, but as always, you need to practice. Practice makes perfect. And we only have one more section, and then unit test coming up soon. So unit test soon. All right. See ya.